welcome to the IEEE Cloud Computing Initiative's introductory video on the topic of big data. In this video, you'll learn a little bit about the whys and whats and hows of big data, where it's going, and some of the key concepts associated with it. We hope that you'll enjoy this video and that you'll learn something from it and maybe get some pointers about where you can learn more. My name's Mark Davis, and I'm the Big Data Lead for the IEEE Cloud Computing Initiative. In my day job, I also build big data computing technologies. So let's get started. So first off, what is big data? Well, there's a lot of ways to describe it, and it certainly is a phrase that's been hyped quite a bit recently. But the idea of big data is when an organization has enormous transactional data, the traditional data that they use to run their organizations, things that live in databases, and they've been accumulating enormous unstructured information, or maybe some unstructured and semi-structured information. These might be things like log files associated with their web servers. It may be machine data that's being generated by logs and other types of system information. This may be industrial control data. This may also be blogs, tweets, and posts that are going into various types of online social media technologies and that are about their organization. And it may be also the internal documents and emails and PowerPoints and so forth that thrive and live within the organization. Basically, all of that data is generally either too big, too unstructured, or too fast for technologies like databases. Now, you can scale traditional relational databases in a lot of different ways, but coping with all these different types of data has turned out to be problematical for them. And there's been a general realization that started in the mid-2000s, the middle of the first decade of the 21st century here, that new tools are needed to be able to deal with that data and to be able to do it in a cost-effective manner. So one other way that people characterize big data is in terms of volume, variety, or velocity. There's so-called 3 V's. Volume simply means the data is big. We have a lot of it. It grows every day. Variety is the topic of the different types of data that you want to handle, whether it's structured, unstructured, or semi-structured. And then velocity is the pace at which that data is arriving within your systems. A lot of people like to expand on volume, variety, and velocity, or drop it altogether and refuse to use it because it's kind of overplayed. And those who want to add to it will talk about things like veracity and value to an organization. And so they come up with 4 or 5 V's to complement it. But this is a short way to characterize big data. And I wanted to introduce it so you're familiar with it because you may hear it elsewhere. So what big data technologies found was within organizations that they had reached the limits of traditional data management methods. Organizations wanted to start using all of their data, not just transactional data related to sales reports or the core line of business sort of decision making for, say, the basic signals for operating a power plant and things like that. They wanted a lot more data to be brought in, and they wanted to then transform that data into actionable intelligence. And then an additional thing that a lot of people talk about is anomaly detection, or finding the needle in the haystack, the long end of the tail of long-tail distributions, things that are improbable that they need to understand or be able to treat as actionable. Let's take some specific use cases. For example, social media. And in addition to Google sort of reinventing its search architecture, where some of the core concepts of modern big data started from, another really sort of foundational part of the big data story comes from social media companies like Yahoo and Twitter and Facebook. Specifically, as they set up their web servers to be able to serve you pages and give you news and let you do web-based email and things like that, the web servers themselves were generating huge amounts of log files, and they really wanted to be able to make use of all that log data. And that log data is what we might call semi-structured. It looks like a table, but it hasn't been really imported into a relational database. And one of the use cases was, for example, what if you could group users based on their behavior patterns, so that individuals who like sports, like soccer, that they go to those pages a lot. Other people are interested in cars or fashion and movies. And if you could group those different users together and understand their behavior patterns, then you could improve their user experience on the site. And admittedly, yes, you could also sell them advertising in a more efficient and targeted manner. So after they grouped the behavior patterns out of these web servers, then the next step that people did was they started building machine learning models of that behavior, looking at patterns and within it and building algorithms that could make predictions, so that if I was looking at a page about a sports player, when I go back to my main news panel, I might get additional pages that are about soccer, and that would improve my user experience. And that means we can recommend news and information, including ads, to people. So this formed one of the core use cases where big data came about, and it becomes big partially because of the variety aspect of the log files being semi-structured, but also based on just simply the scale, hundreds of millions of users in some cases, and also the velocity, hundreds of thousands or millions of posts and tweets happening every minute of every day. Let's look at a different type of use case now, and that's in industrial control. And this is a growing use case that's associated with what we call the Internet of Things, and that is where we have more and more sensors embedded, all of which are communicating state, communicating change, communicating failures, to allow organizations and even individuals to improve the quality of the systems and their interactions with them. So you have millions of data points from sensors, gigabytes coming back from, for example, a jet engine turbine. Cars are generating huge amounts of, automobiles are generating huge amounts of data every moment concerning performance. And the early developments in cars, for example, were just to use oxygen sensors to adjust the amount of the fuel-air mixture going into the engine. But as time has progressed, we have the ability to interactively adjust magnetic shock absorbers and things like that. So you can, as you collect all that, you can optimize the systems. You can also analyze failure modes and proactively improve products. So you can begin to predict, for example, when tires are going to need to be replaced on your fleet of trucks. You can begin to predict when maintenance needs to be done so you don't have catastrophic failures on aircraft. And you can proactively improve products by determining where you're going to spend the most on maintenance associated with those products, and be able to improve those systems in such a way that you can avoid that kind of maintenance as time goes by. So with that, I'd like to thank you for participating and watching this video, and there are a lot of resources out there, including the Apache Foundation. Just do a Google search on on Apache and open source, and you'll find it. And we also at the IEEE Cloud Computing Initiative have other big data resources, including other videos that we'd like to invite you to watch. Thank you very much for your time.